Assalamualaikum warahmatullahi wabarakatuh. So today we are from group 8. We are going to explain about sampling. I am Muhammad Safrul Hidayat, and also my group member Rizky Anissa and also Muhammad Fuad Parakwan. Okay, let's continue to the material. For the first part will be explained by Rizky Anissa.
Okay. Assalamualaikum warahmatullahi wabarakatuh. The first page of this presentation is about the sample size. Okay, next please. But before we continue to the sample size, it is about like a question of sampling raised directly out of issue of the definition of population on which the researcher will focus. And the researchers must take sampling decision early in the overall planning of a piece of the researchers. And there is so many factors such as expense of the time and accessibility, frequently prevent researchers and from gain information from the whole population. And then there is no clear-cut answer for the correct sample size, depend on the purpose of the study and the nature of the population under scrutiny. However, it is possible to give some advice on this matter. And the number of variables researchers set out the control in their analysis and the type of statistical test that they wish to make must inform their decision about the sample size prior the actually researcher is undertaking. And remember, sample size is also determined to some extent by the style of the researchers. Next. And also, therefore, they often do need to be able to obtain the data from a smaller group or subset of the total population in such a way that the knowledge gained is representative of the total of population under the study. This is smaller group or subset is the example. Experiences, the researchers start with the total population and work down to do some samples. By the contrast, less experienced researchers is often work of the bottom to the top. That is, they determine the minimum number of the respondents needed to conduct the researchers. And the sample size is also constrained. First, cost in terms of time. Number two, money and stress. Number three, administrative support. Number four, the number of researchers. And the last is resources. Correlation research require a sample size of no fewer than 30 cases. That is, casual, cooperative, and experimental methodologies require a sample size of no fewer than 15 cases by Board, Work, and Gall 1979. Next. And the sample size has to begin with an estimation of the smallest number of cases in the smaller subgroup of the sample and work up from that rather than vice versa. Wait a sec. Okay, next. And then let's continue for the sample size. Sample size is probability random sample that can be determined in two ways. The first is by the researchers exercising the prudence. Number two, ensuring that the sample is represent the wider of the future of the population with minimum number of cases. In other way, approach to determine sample size for a probability sample is in relation to the obedience level and sampling error by Borg and Gall 1979 suggests that as a general rule, sample size should be a large where there is first many variables. Number two, only small differences or small relationships. Number three, sample will be broken down into subgroups. Number four, sample is heterogeneous in terms of the variable under the study. And the last is reliable measure of the dependence variable are unavailable. Okay, let's continue. According to Oppenheim 1992, add to his view that the nature of the scale to be used also extern an influence of the sample size. For a nominal data, the sample size may well have to be large than interval and ratio data. And then the next it's according to Borg and Gall, set a formula-driven approach to determining sample size, such as using a correlation table for the correlation studies, is available in most texts on statistics in reverse, as it were. To determine sample size, looking at the significant level of correlation coefficient and the reading of the sample size usually required to demonstrate that the level is significant. Okay, the next is about qualitative and quantitative data. Hold up. Okay, let me give some example for these researchers that use qualitative data or maybe quantitative data. For the example is a correlation significance level of 0.01 level would require a sample size of 10 if its estimate coefficient of correlation is on 0.65, or maybe a sample size of 20 if its estimate correlation coefficient is 0.45. I'm sorry. And the sample size of the 100 if its estimate correlation coefficient is on 0.20. And in self-cooperation can be seen the largest, the sample size, or maybe the smaller, the estimate correlation coefficient can be to be demand significant. I'm to be significant. And this example can be used both of qualitative and quantitative data. By the essential requirement is that the sample representative of the population from which it's drawn in a dissertation concerned with a life history. And then for that example, it's just about the example and the qualitative data in this material is about it is were like of 30 highly able student is similar is similar socioeconomic background following a level biology course. Just like the example from the first example that I already told. And then the qualitative data is where there is a heterogeneity in the population, then the largest sample must be selected on some basis that respect that heterogeneity. This from a staff of 60 secondary school teacher different by the gender age. So for make the solution from that example by using qualitative data, you can where is it compared with some of other cases. And then the next, the quantitative data will be explained by Muhammad Waisaf Hidayat.
Okay, thank you. Next, I will continue about quantitative data. In quantitative data, for a precise sample can be calculated according into two, the level of accuracy and the level of probability that the researcher requires in her work. So here she can then report in her study the rationale and the basis of her research decision. Uh, this is the example. A teacher or researcher wish to sample opinions among 1,000 secondary school students to 10-point scale ranging from 1. The number 1 is actually totally unsatisfactory to 10, absolutely fabulous. So her own students rate, rated the activity an extracurricular event as follow. The mean score is the 7.27 with standard deviation with 1.98. How many of the 1,000 students does the does it need to sample in order to gain an accurate or reliable assessment of what the whole school in total 1,000 thinks of the extracurricular event? So this is a simple calculation or a formula by Bla, Blalock 1979. He shows that if she happy to be within point, if the within plus or minus 0.05 of a scale point and accurate 19 times out of 20, then she require a sample of 60 students out of 1,000. If she happy between to be within the same scale point, uh, zero point 0.5, and accuracy in 99 times out of 100, then she requires a sample of 104 out of the 1,000 students. If she happy with the same scale point, I mean in the differentiate or range of the scale point zero point 0.5 and accuracy in 999 times out of 1,000, then she requires a sample of 170 out of the 100 point. If she is a perfectionist and wish to be within in plus or minus scale point in 0.25 and accuracy in 999 out of 1,000, then she requires a sample of 679 out of 1,000 students. But determining the size of the sample will also have to take account of attrition and respondent mortality. In example, that some participants might leave the research or fail to return the questionnaire. So this is a point that I explained. And then for the next is sampling error. So If many samples are taken from the same population, it's unlikely that they will have all characteristic identical, or maybe the answer, or maybe the characteristic might be same with each other or with the population. Their means will be different. If we take a large number of sample from the population and measure the mean value for each sample, then the sample means will not be identical. So for the box in the box 4.3, this is the distribution of sample means showing the spread of a selection sample means around the population mean. So like what I explained before, uh, this is the population mean. So if if they are identical, it might be that uh, these two these two means is identical each other from the left and the right, because it's in the same position. So this is what the mean, that it is the meaning of identical sample. So for the next, oh yeah, this phenomenon explains by reference to the central limit theorem, which is derived from the laws of probability. So the first is, if random large samples of equal size are repeatedly drawn from any population, then the mean of the sample will be approximately normally distributed. Second, if the distribution of sample means approach the normal distribution as the size of the sample increase, regardless the shapes, normal or otherwise, the parent population from Hopkins and class in 1996. So moreover, the average or mean of the sample means will be approximately as same as the population mean. And also Ross and Sullivan remind us that 95% of all samples means fall between plus or minus 1 and 0.96 error of sample and population means. By drawing a large number of sample of equal size from a population, we create sampling distribution. We can calculate the error involved in such sampling. So this is are the standard definition of the theoretical distribution of sample is a measure of sampling error, and is called the standard error of mean, or SEM. So SE, where the standard error in this, where SD per n, with the SDS is the standard deviation of the sample, and n is the number in a sample. So strictly speaking, the formula for the standard error mean is SD-pop. SD-pop is the standard deviation of the population. So However, we as we are usually unable to ascertain the standard deviation of the total population, the standard deviation of sample is used instead. So between these two, usually uh, because we are unable to ascertain, we usually the sample standard SDS or standard deviation sample used instead. Standard error of the mean provides the best estimate of sampling error. Clearly, the sampling error depends on the variability in the population as measured by SD-POP as well as the sample size by Ross and Sullivan in 1993. As the sample increases, the sampling error decreases. Hopkins class and class in 1996 suggests that unless there are some very unusual distribution, the sample of 25 or greater usually yield a normal sampling distribution mean of the mean. So the next is the standard error of proportion. So a simple calculation or standard error of proportion is like this, like what I showed here, where the P is the percentage in favor, the Q is 100% minus P, and the N is the sample size. This formula assumes that each sample is drawn on a simple random basis, a small correction factor called the finite population correction or FBC is generally applied as follows. For the SA proportion is like the that where F is the proportion included in the sample. So the next is I will explain about the representativeness of the sample. So the researchers will need to consider the extent to which it is important that uh, the sample in fact represents the whole population in question. If it is to be valid sample, the researchers will need to be clear what it is that is being represented. So the example is uh, a national newspaper reports that one person in every two suffers from breakage. This is a 50% change. This headline stirs alarm in every doctor's surgery through the land. However, the newspaper fails to make clear the parameter, the study which gave rise to the headline. So, turn out that the research took place in number one, in a damp part of country, and two, in a part of country where are so many people that are old, and also three, in area of heavy industry where are so many workers that might be suffer from back age. Number four, the place number four, it is only using two doctors record only. So this is so that these four variables, climate, age, group, occupation, and reported incidents, were seen to exert a disproportionate effect on study. The newspaper report uh, sensationally generalized beyond the parameter of data thereby overlooking the limited representativeness of the study. And the next is the access to the sample. So the researchers will need to ensure not only access is permitted, but is in fact is practicable. The first one is similarly access to sensitive area might not only be difficult but problematically both legal and legally and administratively. Second is in some sensitive areas, access to a sample might be denied by the potential sample participants themselves. And the third, access might also be denied by the potential sample of participants themselves for very practical reasons. Further, access might be denied by people who have something to protect. Then, not only might access be problematic, but its corollary release of information might be also problematic. So this is are the 5 point about uh, to make researchers to make sure this 5 point in access to the sample. The next is sampling strategy to be used. There are two main methods of sampling. The researcher must decide whether to option for a probability or a non-probability sample. The difference between them in a probability sample, the chances of members of wider population being selected for the sample are known. Whereas in a non-probability sample, the chances of member of the wider population being selected for the sample are unknown. In the former probability sample, every member of the wider population has an equal chance of being included in sample. In the latter, or in the non-probability sample, some members of wider population will definitely be excluded and others definitely included. So, with these two points, I will explain about a bit about probability sample. So there are several types of probability sample. In a probability sample, because it draws randomly from a wider population, will be useful if the researcher wish to be able to make generalization because it seeks representativeness of the wider population. In these types of probable samples are first one is simple random samples, systematic samples, stratified samples, cluster samples, state samples, and also multi-phases sample. So, and the next will be explained by Fuad Barakwan.
Okay, I will continue explanation about there are several probability samples. The first sample random sampling. In sample random sampling, each member of the population under study has an equal chance of being selected and the probability of a member of the population being selected in unaffected by the selection of other member of the population. Each selecting is entirely independent of the next. The method involves selecting at random from a list of the population or a sampling from the required number of subjects for the sample. By using a table of random number set out in matrix form or these are reproduced in many books and quantitative research method and statistics, and allocating these random numbers to participant or case. Hopkins and Glass 19 and 96. Because of probability and chance, The sample should contain subjects with characteristics similar to the population as a whole, some old, some young, some tall, some short, and some rich, and the last some poor. And the next, systematic sampling. This method is a modified form of sample random sampling. It involves selecting subjects from a population list in a systematic rather than a random fashion. For example, if from a population of say 2000, a sample of 100 is required, then every 20% can be selected. The starting point for the selection is chosen at random. One can decide how, how frequently to make systematic sampling by a sample size statistic. The total number of the wider population being represented divided by the sampling size required. And the next, stratified sampling. Stratified sampling involves dividing the population into homogeneous groups, each group containing subjects with similar characteristics. For example, group A might contain males and group B females. In order to obtain a sample representative of the whole population in terms of sex, a random selection of subjects from A from group A and group B must be taken. If need, the extent proportion of males to females in the whole population can be reflected in the sample. To organize the stratified random popul, sample to stage process. The first identify those characteristics which appear in the wider population, which must also appear in the sample. And the second is randomly sample with this group, the size of each group being determined either by the judgment of the researchers or by reference to box 4.1 or box 4.2. And the next, cluster sampling. By cluster sampling, the researchers can select a specific number of schools and test all the students in the select school. Geographically close cluster samples are widely used a small-scale research. In a cluster sample, the parameters of the wider population are often drawn very sharply. Researchers, therefore, would have to comment on the generalizability of the finding. And the next is stage sampling. Stage sampling is an extension of cluster sampling. It involves selecting the sample in stage, that is, taking sample from sample. Using the large community example in cluster sampling, one type of stage sampling might be to select a member of school at random, and from within each of these schools, select a number of classes at random, and from within those classes, select a number of students. Marizon 90 and 93 provides an example of how to address the sample in practice. Let us say that researchers want to administer a questionnaire to all 60 years old and each of 11 secondary schools in one region. By containing the 11 schools, she finds that there are 2,060 years old enrolled. And the last, multiple sampling. In stage sampling, there is a single unifying purpose throughout the sampling. In the previous example, the purpose was to reach a particular group of students from a particular region. In a multi-phase sample, the purpose changes at its pace. For example, at phase 1, the selection of the sample might be based on the criterion of geographic. Phase 2 might to be an economic criterion. Phase 3 might be based on a political criterion. Next slide, please. And the next, non-probability samples. The selectivity which is built into a non-probability sample derives from the researchers target a particular group in the full knowledge that it doesn't represent the wider population, it simply represents itself. This is frequently the case in small-scale research. And there are several types of non-probability sample. The first is convenient sampling. Convenient sampling, or as it is sometimes called accidental or opportunity sampling, involves choosing the nearest individual to serve as respondent and continuing that process until the required sample size has been obtained. Captive audience such as student or student teacher often serve as respondent based on convenient sampling. The researchers, of course, must take pains to report this point, that the parameter of generalizability in these types of sample are negligible, and convenient sample may be the sampling strategy select for a case study or a series of case studies. And the next, quota sampling. Quota sampling has been described as the non-probability equivalent of stratified sampling by Bailey 90 and 78. Like, like a stratified sample, a quota sample strives to represent significant characteristic or strata of the wider population. Unlike stratified sampling, it set out to, to represent this in the proportion in which they can be found in the wider population. And the next, purposive sampling. In purposive sampling, researchers handpick the case to be included in the sample on the basis of their judgment of the typical in this way. They build up a sample that is satisfactory to their specific need. As its name suggests, the sample has been chosen for a specific purpose. For example, one class of students has been selected to be tracked throughout a week in order to report on the curricular and pedagogic that which is offered to them so that other teachers in the school might compare their own teacher to that reported. And the next, dimensional sampling. Dimension sampling is a further refinement of quota sampling. It involves identifying various factors in interest in a population and obtaining at least one respondent of every combination of this factor. Thus, in study of rich relation. For example, researchers may wish distinguish first, second, and third generation immigrant. Their sampling plan might take the form of a multidimensional table with ethnic group across the top and general down the, the side. And the last, snowballing sample. In snowballing sample, researchers identify a small number of individuals who have the characteristic in which they are interested. These people are then used as informants to identify or put the researchers in touch with others who qualify for inclusion, and these in turn identify yet others. Hence the term snowball sampling. This method is useful for sampling a population where access is difficult, maybe because it is a sensitive topic or where communication network and underdeveloped. The text for the researchers into establish who are the critical or key informant with whom initial content must be made. Next, please. And the conclusion. The conclusion is the message from this chapter is the same as for many of the others, that every element of the researcher should not be arbitrary but planned and deliberate, and that, as before, the criterion of planning must be fitness or for purpose. The selection of a sampling strategy must be governed by the criterion of suitability.
Okay, thank you. Maybe that's all for from our group. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.